first problem will be over here. Yeah. Go. Second one, third one, fourth one. Okay. For the entirety of this video, if you so choose, you can pause before every problem and then have a look at whether your solution tracks. Let's begin. So firstly we have x multiplied by 2x plus 1 all equal to 0. So our good old friend zero product rule comes into play. So therefore a is equal to 0 or b is equal to 0. So that's our a, which means x is equal to 0, or, well, 2x plus 1 is equal to 0, means 2x is equal to negative 1 and x is equal to negative 1 over 2 because we divide both sides by 2. Should have enough space for the second one. Well, these words mean go directly to the formula. Do not pass go. Do not collect 200 rand. So let's get going. We have 5x squared plus 2x minus 6 all equal to 0. Let's remind ourselves what the formula looks like. Well, ax is just equal to minus b plus minus square root of p squared minus 4ac. Everything divided by 2a. So let's have a look at that. That's our a value. There we get our p value. And negative 6, of course, would be our c value. So what does this translate to? Well, x is just equal to, well, minus p plus minus square root of some stuff, p squared minus 4 times a times c, and then there's 2a, which is our divider. So let's have a look. P is just 2, and then a is 5, c is negative 6, and a, of course, well, its value isn't going to change, not just like that. Yeah. Lastly, x is equal to, if your calculator works, 0.91, rounded off to 2 decimal places, of course, or it's going to equal negative 1.31. And that's how that's done, and that's done. But we need our space back. So let's get going with that. Boom, that should do it. Why isn't that disappearing? Go away. You too. So next we have a quadratic inequality. So 2x squared minus 2 is greater than equal to 3x. So for this we need to place everything in standard form, which just means in this case moving 3x or transposing it by subtracting it from both sides. So we'll have 2x squared, of course. On the right hand side we already have our 0 in place, but on the side we need to also subtract 3x, because what you do on the left you do on the right, and of course this is an inequality. Ooh, that's a bit rough. There we go. So let's get to factorizing, because this is quadratic. All those skills still apply. And of course we need negative 3 in the middle, which means it's minus 2 and plus 1. Now from this form we are just looking for critical values. Right, these critical values tell us where this inequality equates to 0, or from a graphical perspective, where the parabola crosses the x-axis. Because this is quadratic, you can see in standard form it does translate into a parabola or quadratic function, if you will. Well, there we have our critical values, well, from solving those two simple linear equations. Well, now that of course we've made sure that our leading coefficient for x squared, of course, is positive, which means we have a smiley face parabola. Smallest value on the left, biggest value on the right. There are critical values, of course, and we want to know where this parabola is, obviously above the x-axis, above. So that region and that region. And if we were to have a light shining all over the place, of course it would throw a shadow to the left and to the right from where the arms are blocking it. And these are the values that we are interested in. Those are, of course, x being less than or equal to -half, or x being greater than or equal to 2. And that does that. Let's get our space back again. As well, delete that 2. Delete. Final. Last one's a bit finicky. Come on, Mr. K, you can do better than that. Yes. Well, let's get some ink back, because we still have one more to deal with, which is just the square root of 2x plus 5 minus 3 over the square root of 2x plus 5 all equal to -2. Well, right off the bat, I don't like what's going on here. It's not just a square root, it's got a fraction in there as well. So let's just simplify this equation by using substitution. And for that, we'll just say let the square root of 2x plus 5 equals some letter k. Well, what does that do to this equation? Well, there's a 2x plus 5 being square rooted, so that becomes a k, and then we have -3, of course, for that one. We'll substitute another k, and that's all just equal to -2. Well, that's a lot better. Let's multiply everything by k, because this fraction is still bothersome. Well, k times k gives us k squared. Multiply this k over here, it cancels out, so we'll have -3. And of course, what we do to the left, we must do to the right. Multiplied by k over there, and we have -2k. Well, it's quadratic, wouldn't you believe it? So we'll add 2k to both sides, because we want a 0 on the right hand side. So it's 2k, of course, being added, and then -3, everything equal to 0, as previously stated. Well, this is rather simple to factorize. K plus 3, k minus 3, no, not -3. That's what rushing does. Well, 3k minus k, it's all good. Therefore, k is equal to -3, or k is equal to 1. But remember, we were never asked to solve for k. So let's get back to what we started over there and undo it. Therefore, we have the square root of 2x plus 5 being equal to -3, or square root of 2x plus 5 being equal to 1. So let's deal with them one by one. Well, we're going to square both sides and deal with it over here. So that will, well, the square root of 2x plus 5 just undoes the square root. So we'll have 2x plus 5, and then -3 all squared is 9. So subtract 5 from both sides. We'll have 2x being equal to 9 minus 5 is equal to 4. Divide both sides by 2. And we'll have x being equal to 2, of course. For this one, the other one, we can do that in blue. Of course, we have to square both sides again. So we'll have 2x plus 5 being equal to 1, because 1 squared is just 1. 2x, subtract 5 on both sides, being equal to -4, and x being equal to -2. Of course. Rightio, and we are not done. Let's just test these values. Well, if you place a 2 in here, that becomes 4 plus 5, and the value we'll be looking at is 3. Remember, we are using this 2. So this bottom value becomes 3 as well. Well, let's have a look. 3 minus 1 is equal to positive 2, which is not equal to -2. Let's take that away, because we still need to do another test. but that makes this invalid as a solution. Let's test minus 2. Well, if we have minus 2, we'll have minus 4 plus 5. Let's do that in another color, let's say purple. Well, then we get minus 1 as a value for that entire thing. And then of course over here, not minus 1, plus 1, sorry, minus 4. Minus 4 plus 5 is equal to positive 1, and the square root of 1 is just 1. The same would count over here, so then it would become 1 minus 3, which is equal to negative 2, and negative 2 is equal to negative 2, which means this value passes the test, and that's the valid value we have for x over there. Radio. Hope you had success. Always a good idea to double check where we went wrong and where we went right.